All right, welcome to Statistics, Unit 6 for Math 40S. Again, this will be a continuation of our grade 12 math, getting you ready for the exam. As always, please put your name up in the top right, and let's continue. All right, getting started. 3. So we have order these prices of long haul trucks from least to greatest. So smallest to biggest. Well, our smallest number is 80,000. Then 89. 100. Then it was 96.4. Then 101.4. Then 101.9. Then 105.3. Order these masses of hiking packs from greatest to least. So biggest, 19.175. Then it would be 16.7. Then 16.43. Then 16.183. Then 13.999. So 7 is bigger than 4, which is bigger than 1. If you are confused, that's how it works. Okay, number 2, we have a histogram, which is a type of graph that shows organized data into intervals of equal size. The touching bars show the frequency. So this is about a fishing tournament that was held in Chilliwack, British Columbia. It shows the length of sturgeon caught on day 1 of the tournament. In which length interval were the most sturgeon caught? So we have length intervals. We have from 60 to 100, 100 to 140, 140 to 180, 180 to 220, and 220 to 260. So between 60 to 100 centimeters, we had 22. The next size, 100 to 140, we had 43 fish caught. That's how this graph is read. So the question asks, in which were the most sturgeon caught? Well, the interval that had the most was 43 right up here, which is between 100 and 140. So between 100 and 140. B, how many sturgeon were caught on day 1? Well, we just have to add all of the circled totals in the graph. So 22 plus 43 plus 28 plus 11 plus 5, and that will equal 109. 109 sturgeon were caught. Using the data from the histogram to complete the frequency. So from 60 to 100, we had 22 fish. From 1 to 140, 43. Then 28, then 11, then 5. So this is called a frequency table. The table that shows the number of items in each interval. So instead of seeing it as a graph, you just see it as a chart. D, the average length of the sturgeon caught in the tournament was 134.66. In which interval of the frequency table does that belong? So this belongs in that one. So we would write it belongs in the frequency interval of 100 to 140. A sturgeon caught on day 1 was 180 long. Into which interval of frequency table does that fit in? That would fit into the 180 would fit into 140 to 180. Awesome. Hint. Each interval includes numbers that are greater than the lesser value and up to including the greater value. Okay, so that's why it goes up to 180. All right. Number 3, so if you haven't guessed, this statistics unit is about percents, frequencies, and mode, median, kind of averages, that kind of thing. So convert each fraction. In your calculator, all you got to do is 15 divided by 20 times 100 is 75%. 23 divided by 45 times 100 is going to give you 51%. Calculate each percent. If you don't remember this from earlier, let me see if I can pull up the calculator app here. Calculator. Good. So it says, let's see if I can do this on this one. 25%, so 0.25 of is times 299,900 equals. There we go, that's our answer. 74,975. And let me check. Yep, it's good. Okay, same thing with this one. 20% of 1.83. If you put in your calculator, it'll be 0.366. So that's how you do that. Okay, the ages of the players on the basketball team are 16, 15, 17, 18, 14. So all those numbers. Record the ages in order from least to greatest, smallest to biggest. So we got 14. That's our smallest. Then a 15. Then another 15. Then do we have any more? Nope. 16. Then looks like 17. 17. 17. 17. 17. Oh, I missed a 16. So I'm going to erase that one, put 16 there, 17. Then we had 3 18s, 18, 18, 18. Good. Create a frequency table for the data. So this says age, and this says number. Or hashtag. That means number, by the way. 14s, 15s, 16s, 17s, and 18s. How many do we have? 15s, we have 2. 16s, we had 2. 17s, we had 1, 2, 3, 4, 5. 18s, we had 3. Good. Noel says that the middle age is 16. Rob says that the middle age is 17. What reason might each give? Noel says that the 2 ages are less, that 2 ages are less than 16 and 2 ages are more. So if you can see, Noel says there's 14 and 15 and then 16. Erase that little thing. 17, 18. So there's 2 behind and 2 in front. That's why 16 is the middle for Noel. And for Rob says that 17 is the middle because we recorded up here 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. 17 is the middle one up there on part A. So that's why he says 17. Both are right. Depends how you look at what the middle is, which is what this unit is all about. Okay, we got Rhoda is an event planner. This bar graph shows her seating plan for a charity dinner. So we have table, A, B, C, D, E, and we have number of guests. How many guests will there be at the dinner? So that's just adding them all. So that's 9, 12, 10, 11, 8. And that equals 50. Rhoda has been asking to revise her seating plan. The client wants to have the same number of guests at each table. How many guests should Rhoda seat at each table? Well, how many tables do we have? 1, 2, 3, 4, 5. 50 guests divided by 5 is 10 per table. Good. Draw a horizontal line on the bar graph to represent the same number of guests at each table. How could guests be moved to fill tables with not enough guests? So 10 is right there. So we'll take 2, move them there, take this one, and move them there. Basically, that's what we would do. So you just write that here, what I just said about moving 2 from B to A and moving 1 from D to E. Okay, so that's the intro to your unit. Next section, we're going to talk about 3.1, and it's really mean. See you next time.